Hello everyone, Siddharth this side, and today we will be solving another question on Geek for Geeks, which is trapping rainwater problem. So what we have to do in this problem is that each element in this array is representing the height of the block, and we have to return the total amount of water which can be trapped between these blocks. So, and the width of each block is 1 unit. So if we replace our block with water, the amount of water will going to be the 1 unit. So there will be two approaches to solve this problem. First one is the brute force method, and the second one is two pointer approach. So we will be discussing both the approaches in this video, and let's start by the brute force method. So in the brute force method, what we will be doing, uh, so this is the array in the first example. So in the brute force method, what will we will be doing, for the each element, for each element in this array we will be checking, we will be finding the uh, height which is maximum to its left, and we will be finding the height which is maximum to its right. Why we are finding this, let's see. Suppose we are at the 0th element, and so the maximum height to its left will going to be 3, and the maximum height to its right will going to be 4. So let's draw the block as well. So this is 3, and here is 0, here is 0. Currently we are at this element, and this is 2, so which will going to be a little smaller than 3, and then there is 0, and then there is 4. So now for finding the trapped water by each block, uh, so why we are finding the left and right max? Because we want to find the trapped water by each block. So how can we find that? So currently we are at this zero element of our array. So the trapped water by this individual block will going to be the minimum of these two heights, which is 3, and minus the height of this current block, which is 0. So the answer will going to be 3. So for this block, the maximum trapped water will going to be 3. So we will add this amount to a trapped water variable. So after traversing to each element, we will able to find the total amount of trapped water. So this is the concept you can use for finding the total trapped water using brute force method. But this method will take omega of n square time complexity. So obviously we have to optimize this solution. So for optimizing the solution, what we will be doing, instead of initializing two loops, we will be keeping track of our left maximum and some condition uh, simultaneously from the left side and the right side, and we will adding a trapped water. So in this way, in the single traversal, we will able to solve this problem. So exactly what we will be doing, uh, we will be having 2 to 3 conditions. The first condition is that we will create 2 pointers, and we will process the element at the pointer which is minimum. If the pointer, suppose our current the pointer will going to, left pointer will going to be at 3, and the right pointer will going to be at 4. So we will process 3 first. Because why we are processing at 3? Because the smaller block only contribute to the amount of water that will be getting trapped in the future. Because this no matter the height of the greater block, the extra amount will not matter, because there will be no block which will be helping for that water to get trapped. So we will be processing only the elements which is smaller, whether it is on left side or it is on right side. So first condition, we have to check which is smaller. So left or right, we have to check which element is smaller. So this will going to be our first condition, and after this condition, we will be keeping track of the left maximum and right maximum in the both condition. So how can we keep track of the left maximum? uh, each element we will compare whether it is less than our left maximum or not. If it is less than our left maximum, then we will add trapped water, otherwise we will update our left maximum. Why we are updating our left uh, why we are updating our left maximum? Only in the case if we find the element greater than our left maximum, because we want to trap the water, and the trapped water will only in the case if we encounter a smaller element. Because if this is 3 and if we find another block which is 3, then no water will get trapped. The trapped water will only in the case if we encounter the element less than 3. So this is the concept that we will be using. So there will be two conditions. First condition uh, first condition will have this condition also, and the second condition will have this condition also. So both the pointer we have same condition. So now move on. We will be moving on to the coding part. If I suppose that you guys have understand what I want to say, so let's start the coding part. If you haven't understand till now, as soon as I will start coding, you will get the whole idea to solve the problem. So let's start. So first, what we will be doing, we will be creating our left maximum variable, and we will initialize it to 0. Then we will creating a right maximum, and we will initialize it to 0 as well. After that, what we will be doing, uh, now we will be creating two pointers, which is int left is equals to 0 and int right will pointing to a last element of our array, which will going to be n minus 1. Now after this, what we have to do, we have to return the data type as long, so we will create long trapped water and we will initialize it to 0 as well. Now what we have to do, we have to start traversing into the array. So we will be creating an while loop. You guys have clearly understand why we are initializing while loop, because in the two pointer approach we have to initialize the while loop. So left is less than or equals to right. Then only what we have to do, we have to check our first condition. So the first condition is we have to process the element only which are minimum. So if our array, the element at ith index left index, if that is less than array right, so we have encountered the minimal element at our left pointer, so we will be processing that now. Now how can we process our left pointer? We have to check if our array, we have to check if our element at the left is greater than our left max. So if we have encountered the element greater than our left max, then we have to update our left max to our array left. Why we are updating if we encounter the greater element? Because this case will not trap any water. The water will get trapped only in the case if we encounter the smaller element than our left max. So in the else case, we will be updating our trapped water. So trapped water will going to be plus equals to, and what will be the value of trapped water? So the value of trapped water will going to be the height of the left max, which is 3 suppose, and height of the current element, which is 0. So 3 minus 0. So trapped water will going to be left max minus the current element, which is array left. Now this is the work in the left side. Now we have to do this to the condition where we encounter the element which is minimal in the right side. So for that, let's we have to, after else part, we have to move our pointer as well. So left plus plus. Now let's move on to the else condition. So where we can write our else condition, second else condition. So in the second else condition, we have encountered the element at the right side which is minimal. So now we have to check if our array right is greater than array right. Sorry, array right. I think we have done the mistake here as well. Array left is greater than left max, or array right is greater than our right max. Now after doing this, what we have to do? We have to update our right max. So right max will going to be the current element which is array right. Now in the else case, what we have to process? We have to update our trapped water. So trapped water will going to be right max minus array gst, right? Okay, and after this we have to update a right pointer as well, which is right gst right minus minus, and after that what we have to do? We have to return a trapped water. Trapped water. Okay, so I think the code is looking fine. First we have check if the element is minimal on the left side, or it is minimal on the right side. So in each of the condition we have keeping track of the left max, otherwise we will updating our trapped water, and we are doing this same to the right side, and in the end we will able to get the total trapped water. So let's try to run this code now. Okay, where we have done the mistake now. If it is closed here now. Okay, so this if is closed here. There is another if loop. It's on 49. So if left array left is greater than a left max, what we will be doing? We will be updating a left max to array left. So array left. Otherwise, we will be updating a trapped water, which will going to be left max minus array left, and we will be doing same thing to the right side. Now what is the problem? Okay, guys. So this is the typo here. We have uh, mistakenly placed this bracket here. Now let's try to run this code. So now let's try to submit this problem. So all the test cases have been passed. So thank you. See you in the next video. Bye.